Welcome to Terex Bench. Today here on the bench, a Bosch KF-166. Okay, this Bosch is a business radio used for taxi drivers, for buses, for maybe fire department and police and so forth and so forth. And therefore it is really of high quality. Now we want to convert it to use it for repeater operations, and therefore we have to do some alignments and maybe a little bit here and there. We have to convert it from the VHF 2 band, which is the business portion of the VHF band. Our radio, our ham radio band, our frequencies are a little bit lower, around 145 something, and the VHF band 2 goes up to 170 something, which is a little bit higher. So therefore we need to convert it a little bit, and we have to put in new crystals. So these crystals here are especially made for the wanted repeater finally. And therefore, first of all we have to fit in these new crystals, and then we need to go through the alignment, and of course we will check if the radio will work. And of course, since we have to go into the radio, we can see of what quality this radio has been made really already a couple of years ago. So let's start. Let's see what we can do here. Okay, and the radio is from the late 80s, so it is really already a vintage radio. But if you see here the size of the radio, you recognize it is really small and thin. So that was not usual back in the 80s. So normally radios was still a little bit bulky. Also technology was going on, but well, this is really a small one. So it is already exciting to look into it. Okay, so the screws are off, and I can lift here the lid, and here we are already in. And that looks already very nice. So you see back then they already have good PCB quality by the look of it. And we have a hybrid final here for VHF, and that here should be, by the look of it, the tone Squelch, which is a selective calling system. So Squelch will only open when you send right, so the distant station sends the right tone codecs, and only if the tone codecs is right, then the Squelch will open. So that means you do not need to listen to all the conversation which are going on the channel. But if there is somebody he really want to get in contact with you, so that is most likely from your own organization, because only your own organization had the right tone code, right? I mean, that is something we do not really need. So let me pull it off, because we need to get it off here. Simply you see here that is the coding, how the tone code was set. And right, so that is what we do not need, but we need to take the board off anyway, because simply we have down here, so you may see it here and there, we have our sockets where we have to drop down the new crystals, right? And well, you see, we have altogether we have 4 sockets, so that means 2 for receive, 2 for transmit. Since this radio, and you can see it here, so the knobs here are very limited, so we only have 2 channels, 1 and 2, and we can switch it in and out. And then we have here on the microphone, we have here our buttons for our tone squelch, and finally, of course, our PTT and microphone, and a speaker is inside our microphone as well. So you see that this radio really can get operated by very little knobs finally. So that is definitely an advantage for business use. Okay, and since we are now want to convert it to repeater purposes, we may know that on VHF our receive and our transmit is 600 kilohertz away from each other, and therefore we can see here the right crystal is on 145.7875, which is the receive crystal, and our transmitter is on 145.187.5, which clearly shows the delta of 600 kilohertz, which yeah, is normal for repeater use. Now we have to drop these new crystals in, so therefore let me identify which is transmit slot and which is our receive slot. And yeah, let me have a look into our schematic and then we can locate it. Okay, and here is our schematic. So let me zoom it in here a little bit so that we find here our transmitter portion. And you may already see here we have our Bosch crystals, and we are here at our transmitter. So simply you see it is really a very simple schematic here. So that is a so-called clap oscillator, and what we can see as well is here our capacity diode for our FM modulation. Yeah, our schematic is not the best quality, so I have to zoom out a little bit, that it is not so much how do we call it, so that we do not see all the pixels, and when it becomes really yeah, it is not sharp any longer. I can't really read what is mentioned here on the plan, so therefore I really have to go back here to a normal size. But what we can see here is Q501 and Q502, and that is, as I already said, our transmitter portion. So here we have our driver stage, and maybe let me see, and yeah, completely right. So, and here after all of our driver, we have our hybrid here on the left hand side. So that is finally our power amplifier, and therefore we know that we need to look for Q501. So let me see where I have as a board plan. Okay, here's our board plan. Let's see how far we can enlarge it. Anyways, but we can see here Q501 and Q502, so we know we have to drop here our transmitter crystal, and up here then of course our receive crystal. So let's go down here to the radio, and let us simply drop in our crystals. Okay, and so that is the situation here on board, and we found that this here is our transmitter, so therefore here is the 187.5 megahertz, which we want to drop in here. That does not feel right. Let's do it once again. Okay, seems to be fine. And then of course our receive crystal, which is of course our 147.7875, right? And that is the one which we drop up here. So come on, and in. Okay, so our both crystals are in, and of course next step is that I have to connect the radio to the tester, and let's see if we get a tone out of the radio. By the way, you see here that we only have here some little transformers and very limited parts here on this side, so that is not much. So therefore all the parts, so all our resistors and transistors and capacities and what have we, seems to be on the other side of our PCB here, and of course we will have a look to the other side in a bit. But first of all, let's see if we get here something out of the radio with our new crystals inside. Okay, and everything is prepared for our first test. And of course for the first test I have put back here our tone squelch board, since all the signals are running, if you like, here through our tone squelch circuit. So for the first test I have put it back. I mean later when we need to align the radio, you have seen that all our transformers, our HF transformers, are here down below, so therefore we have to take it away, of course, and we have to put some bridges in, yeah, simply to bridge here, you know, the lines which are running here through this tone squelch board. Okay, our communication tester is set to the right frequency, so that means 145.7875, and yeah, simply let's switch on here our radio, and we do not hear nothing, but what you see is that here our radio is indicating that finally the radio is switched on, and the yellow or orange one is telling us that there is a communication ongoing on the channel. And that is true because I'm sending here from my communication tester a signal into the radio, but we cannot hear it because we haven't sent out our tone to open finally our tone squelch. I mean, I do not have the tone code, and it is not really interesting to us, but we can of course disable here our tone squelch by this one, and now we have receive, and that is very, very nice. Unfortunately, yeah, I can adjust our tone or our volume here at our volume pot, but unfortunately I can't completely switch it off here. Also, I'm picking here our signal over my monitor, and when we go over here to our tester, we see that of course we have dialed in the right frequency. You can read it in the first line on the left hand side, and you see the level we are pushing here into the radio, which is better than an S9 level anyways. And well, yeah, if I increase here my audio level a little bit, then you see that obviously our synod is not that bad. So you see we have 36 dB, and we really get our 1 kilohertz back, which we are feeding in here with 3 kilohertz of deviation. So that all looks pretty well. Sorry for the annoying tone, but as I said, I'm not able to really switch it off here at our microphone. So that is already very promising. So receiver is working. So now let's see what is going on here on transmit. And yeah, let me see how we can make it visible here a little bit, and let's see what's going on when I press PTT. And we see our power is 0.3 watt, still increasing a little bit. So that seems to be heat dependent, that the power is going up. What you can see as well, we are a little bit off frequency, so 145.188, and it should be 875, so that is a little bit off, which we have to align. And of course we want to align our output power as well, because our radio should have minimum 6 watt output power, so that is too less. But as I told you, it is a business radio which was working on let me go back here to RX, and now I can simply switch it off, so we do not have the tone any longer. And as I said, it is a business radio, so the VHF band is a little bit higher in frequency, so we certainly have to align here our transmitter a little bit more. So yeah, therefore, first of all, now let's pull again here our board, and let's do here the bridges as I already told you, and then let's see what we can do else. Okay, and here we can see all the lines which are running over our the tone squelch. So that is here our transmitter switcher, so that is the audio frequency, and here two more squelch, and what have we, so we finally have 1, 2, 3, 4 bridges which we need to bring in here our radio, and then it should work without our tone squelch board. And here we have our little bridges, little connectors, which we can directly put here onto our contacts, and one has, we simply pull it out, and then we can simply put it here over the contacts, as you can see here. And here we have to do this two bridges, and then over here to this connector, and there we have to do our second two bridges, which we have, come on, go down, yeah. So now we have all bridges we need finally, and yeah, let's see if I'm right and if it is working. Alright, so let me switch in, and again we have nothing. Let me check. No signal. I mean, okay, we get static, and we see that our tone squelch is not indicating anymore here that it is blocked, but only static. Would be a good idea to switch back here our generator. So, and here we are. So that is working with our bridges, of course, and you see we have here our indication for there is a communication ongoing. So let me switch it off, and of course we want to know if our transmitter is working as well. So let me switch to transmit, and again let us push our PTT, and yes, we get our very little output power, but on the other hand you see that the radio is the modulation is working. And when we watch here in this area, you see the deviation. So you see audio and deviation is working as well, and now we can really go ahead with our alignment. And of course, therefore it was important to get access here to all of our transformers, because yeah, these transformers are now needed to do the alignment. So we need to peak the radio on the right frequency, and yeah, therefore let's go according our alignment procedure. Okay, so for our alignment procedure, we have some test points here at the bottom side. So I've already taken out the screws, and we take off here our lid, and wow, already that is really kind of cool. So that is a foil where we have all the test points. So we have here voltages, and we have signal and yeah, that is really unbelievable. And there are cutouts here in this foil where we can go through with our probe to go down to the test point. So yeah, that is really great. And additional to that, I already said this radio is from the late 80s, and have a look. So it is already SMD technique. So yeah, I mean, otherwise how would you get all this stuff in a small radio like this? But yeah, remember, we are really talking about the late 80s, and it was not usual back at that time that everything has been done with SMD technique. So that is great. Okay, so let me put back here my foil, and yeah, let me go here through some tests, and of course I will be back when it really gets exciting. Just to show you how nice this really is. So we are now here for receiver oscillator setting, and what you can see is that we are requested to adjust our L104 for bigger than 130 millivolt RF, right? And yeah, we have to test it at MP mesh point 1. And yeah, let me show you how really nice that is. And here we have our little foil, and we have here MP1, and we simply go here through our foil, and we can test down there for our minimum 130 millivolt RF. And you can see my millivolt meter up there. And let me go back here to mesh point 100 MP1. It is MP1. Let me go down there, and you see we are bigger, or voltage is higher than the required 130 millivolt, so we have 141.7, as you clearly can see. And yeah, that is really how service should be. So the engineers really thought about how maintenance could be done if a radio is once sold. And I mean, you see, today you simply do not get minimum service manual, not even a schematic. And you see really the difference here. So that is how it should be. But today, obviously, we can't expect it any longer. So great. But anyways, let's try to improve here our 141 millivolt simply by turning our L104, because as we have seen, we are at the VHF band 1 in a ham radio, and so we try now to go all these steps and try really to improve it as much as possible. What we have to do here as well is to align our distortion level, right? So of course, for a receiver it is very important to have the lowest ever possible audio distortion, right? Our manual, our service manual, is telling us that we should align for a distortion level smaller than 2%. You see, here is our distortion level, and we are at 2.5, but that is because my audio level is as low as 1.4 millivolt, so that is not right, but I've done it to the lowest position to have not the annoying tone here. But I've done this alignment, and I increase now here my audio level to a good value, and what you see here, we are at 0.8889%, which is really great for all of you who prefer more the synod level. We are at 41 dB, and that is really good. So let me turn down the level once again. So that is really good. So you see, we really can optimize here our level, and we do it here. We can see it here, our level, right? So that is the audio level which we had aligned, and you see, so it is moving forward to get really the last out of this radio here. You all know an important figure for sensitivity is our synod, and what we can see here for 20 dB synod, we Bosch is telling us that for FM it should be smaller or equal 0.7 microvolt, right? So we should be at least at 0.7 microvolt to be in spec. Okay, and what is the reality? So you see, we are around 21, so maybe we can go a little bit lower, right? Let's say here, so we are peaking 20 dB, and the requirement was equal or lower than 0.7, and we are at 0.3, so our sensitivity is better than what the specs are asking for. So that definitely means our radio is when it comes to the receive side, it is fully in spec, and it is even better on our new repeater frequency. So that means all alignments for receiver has been done, so we are fully in specs and better, and therefore we can go over to our transmit portion of this radio. Okay, and I'm already here busy with aligning the transmitter, and well, with aligning the first HF transformers, peaking for the right frequency, and so forth, we are already, when I now press PTT, at 3.6 watt output power, so that is already great. But you see, I mean, we are much closer than at our first test. We are at 18758, so we are still a bit off, and to align now the right frequency as exact as possible, I go over to my frequency counter, and then we do the alignment. Okay, and I'm already trying to get here on frequency. So you see, we are 40 off, 187, and then 539, and it should be 500, but it is here very touchy, my alignment here. So you see how fast it is jumping. So 13 Hertz off 187 kilohertz and 511 Hertz. So you see now we are 8 Hertz of 6 Hertz of 5, 6. Well, I mean, you know, that is more than good. So yeah, that's it. I stop here 187,499. So absolutely fine. I stop here. So that is good. Now our radio is fully on frequency, no doubt. And of course, let's look down here, and you see 1875049. So you see it is absolutely nice by now. So the jumping also happens while I'm talking. And yeah, you see it is really where it should be. So we are at 3.6 watt here for the moment in time. And yeah, let me try to increase now my output power. And you see even that is possible. Let's see what we can do here. So you see now I'm at 12 watt output power, and well, I can go higher, but I think I have to talk to the old man to find out where he want to have the output power set, because yeah, as I said, we are talking about a repeater operation, and normally you do not need that much power when you are not too far away from your repeater. So therefore let me discuss what is the best output power. Okay, our next step is to align the deviation. So therefore you see here the setup that I can feed in my audio generator, and according to our service manual we have to feed in 100 millivolt RMS, 1 kilohertz, but we have to have 20 dB. Can you read it? Yeah, so we have to have a 20 dB attenuator in between. And first of all we have to set our maximum to 5 kilohertz deviation with 100 millivolt and a 20 dB attenuator, which means into the radio we give 10 millivolt, and that is more than our audio level would be, and therefore we can finally adjust the maximum deviation, which should be 5 kilohertz according to our service manual. Okay, so let me set our radio into transmit, and you see we agreed on 10 watt, so 10 watt is the output power, and you see we have a big distortion here on our audio input. I mean, that is for sure, so distortion level is 28%. Because we are overdriving the radio, so that really our deviation goes into the saturation, which should then not be over 5 kilohertz. and let me go over to my modulation meter, because I know that is 100% calibrated, and therefore let me reposition the camera. Alright, and here is our deviation meter, so let me set the radio again into transmit. And yeah, so we are using here the upper scale, and the black figures are what we need. And we see that we are a little bit over 5 kilohertz, and that is a little bit too much. So let me turn it down a little bit, like so. That looks good. Just one check in between. So that is the level check. So if the input level is too low, then you have wrong readings. So now we made sure that the input level into our meter is just fine here, back to FM. And yeah, so that is 5. Very, very good. Now I go back to 10 millivolt at our audio generator, and through our 20 dB attenuator, which means now we have 1 millivolt, and I'm changing here my scale to one moment. I'm changing here to 5 kilohertz scale end. Now our red figures are valid, and there we should adjust it to 3 kilohertz. So that is then the average, and the average deviation during a normal operation. And you see we are below 3. So let me adjust that to 3 kilohertz deviation, and we are, yeah, that looks pretty good. So that is now exactly 3. Let me check if the difference is not too huge between plus and minus peak, but that is good. That is our average, and we are exactly on 3. Let me now once again go up to 100, and okay, maybe we are a little bit too high. No, so that is just fine. So we are exactly on 5. Back to 10 millivolt on the audio, and here back to the red scale, and it is 3. So that means we are really exactly in, right? And that is what we want. And we double check it here with our Roder and Schwarz, and you see here the plus and minus, and it is what we have seen on our Rakaldana as well. So we are in average on 3, so mean is on 3, and that means we are now exactly on frequency, or on the right deviation setting, I mean. And yeah, so that means we are ready with deviation settings, and yeah, we can stop the measurement and the alignment here. And of course what we have to do finally is to put back here our original microphone to the radio, and of course we lock it that it can't go off during operation. because we are always pulling a little bit at the cord, and therefore this is quite nice, so it can't get off. Okay, and that is already the end of the video. So the old man has now a very nice repeater radio, and we stop our video here, and thank you for watching, and catch you next time. Bye.